So this is exam from last year, P1 Physics. And question number 1, very simple. Vector is acceleration. Question number 2. So to determine the density, we will need a balance and a ruler. Because with the balance, we will measure mass. And with the ruler, we will measure the volume of a regular metal cube is a regular shape. Okay. If it wasn't a metal cube, it would have been not ruler, but you would use a measuring cylinder. So D would be choice if it was irregular shape. Question number 3, 2 cameras, distance apart, and the time the vehicle passes each camera is recorded. What do you obtain? The average speed of the vehicle. And the weight is 11,000 Newton and the driving force is 5,000 Newton. What is the opposing force? It will be 5,000 Newton because the weight is acting downwards. So this will be balanced by the normal reaction force of the ground. Question number 5. Which property does not change? We always know this is mass. Question number 6. Block is hung. What do you measure from the block? Well, the 4 choices, they are tricky. The mass has to be in kilograms, so A is the only choice. If you take mass as Newton, Newton is not the unit of mass. The moment can't be calculated and in newtons, and the weight can't be calculated in kilograms. Question number 7. This is the Pythagoras. So you apply Pythagoras, the square of these sides, adding together and then taking square root gives you 5. 4 square plus 3 square, square root whole gives you 5. So what is, when car is accelerating, which forces are balanced? So as you can see, the car is accelerating. So the forward force has to be greater than the air resistance. That's the only chance it will accelerate. The weight is always balanced by the normal contact force. So B is the choice. The force balance, that is contact force and weight. Question number 9. It is asking you to calculate the mass of the beam using this arrangement. So we have a pivot, we have a mass, and the mass is hung, the center of the mass is 50 centimeters from the right hand of the beam, 50 centimeters here. If it is 50 centimeters here, it has to balance this 200 grams times 220 centimeters. So this will produce anti-clockwise moment. The mass will produce clockwise moment. So the clockwise moment has to be anti-clockwise moment, and mass times 50 equals 200 grams times 20. So 200 times 20 divided by 50 gives you 400. The force divided by area gives you the pressure. So B is the correct choice. This question is a bit tricky. So at the depth D in seawater, the total pressure experienced by a diver is 2P, where P is the atmospheric pressure. At which depth is the pressure 4P? Look at this annotation here. We know that at 0 at the surface, the pressure is 1P, 1 atmosphere. When we go down to 1 level, it is telling us this thing. At 1 level, i.e. at D, the pressure is 2P. So we see at 1D, it is 2P. We increase every time we go 1D down, we increase pressure by 1P. So at 2P, it is 3P, and at 2D, it's 3P, and at 3D, it will be 4P. So the 4P pressure will be at 3D depth. The student got it wrong. We have a syringe, we have a gas, we have a relationship, P1, V1, P2, V2. We've input the values, and it says that the volume of the gas doubles when the piston is moved. Temperature does not change. What will be the pressure? If the volume is doubled, the original volume was V, doubled means 2V, pressure was P, and the pressure has to be calculated as P2. So P times V divided by 2V that will 1 over 2 P, so half of the original pressure. So it will halve. 13. Well, all this says about what you have learned, that the mass is unaffected and the weight decreases. Okay, so 14, the relationship between pressure and volume is always inversely proportional. Okay. So inversely proportional can only be alpha and bravo. So why it can't be alpha and why it is bravo? It is because the volume can't be zero. Here, the volume is becoming zero at some pressure. So that's why A can't be right. So B is the choice. Number 15, forces are applied at different distances, which shows the produces largest moment. So you just calculate the moment. Make sure you look at these tricky units, centimeters. So these two can't be your choice. Don't work this out, calculate and waste time. So this will be 30 times 2, 18 times 3. 13 times 2 is 60. That's greater than 18 times 3, 54. Question number 16. The resultant force is always where the car is accelerating and moving in a circle. The car is always accelerating towards the center of the circle. So the D is the choice. Number 17, again, another tricky question. The student thought that we want to know the force, but we don't want to know the force. We want to know the force acting at P, not the force F. So first, we calculate the, the force F in terms of W. You get this here. F is 1 over 3W. Now you use this force and you think of the balanced forces. So the forces are in opposite direction, so they have to be equal in order for the equilibrium. So the F and P are added and equated to W, and then F's value is taken in form of W from here. 1 over 3W plus P gives is equals W, and P will be W minus 1 over 3W, which is 2 over 3W. So the choice will be C. Now, this question, again, bit tricky one. First, you calculate the density from the given data. You are given the pressure, atmospheric pressure, you're given the height. From here, you can calculate the density of the mercury, which is 13,157. I haven't written the units here, but obvious units are obvious. And then you use this density and put it into the column whose height will be 6.57 meters into the same rho GH formula. These three values will give you 75,000 or 0.05 megapascals. Remember, the mega is 10 power 6. So the choice will be B. The student got it wrong. And this one, smallest pressure will be at sea, and it is because the ocean and the lake have different densities. The density of the water in the lake is less dense, so the pressure will be less in the lake. Vector quantity is force. 21, which one is more stable or very obvious? This one having the more base area in contact will be more stable. Question 22, the black and dull will be the good absorbers of IR. Number 23, when the refrigerator is first switched on, what happens to the air? Well, the air will move, the particles, the molecules will move closer and the density will increase. So D is the correct choice here. No other choice matches these two things. Which type of force Earth causes Earth to orbit the sun? It is the gravitational force. Another tricky question here, where we have the mass of Earth single bolt. And then we are given the volume of three bolts rising to 42. That comes out to be 12 cubic centimeters. And you're asked the density of the metal. Look at the word here. The metal and the metal bolt. So these two should click something in your mind that the density doesn't have anything to do with the quantity of the material. If you have 1 kilogram of iron or if you have 1 ton of iron, they both will still have the same density. So we use the mass of the bolts, we use the volume of three bolts, and we get the volume of one bolt by dividing it three. And then using this volume and this mass, we calculate the density, comes out 8.5. Student got it wrong. The physical quantity that doesn't change, it is mass. And dull black surface are good emitters, good absorbers, and poor reflectors. Okay, so C is the correct choice. Here you're asked, look at the words of the gravitational potential energy gain. Okay, so don't ignore everything else. Just look for height you are getting. If you go from here to here, it is 50 meters. Mass times gravitational acceleration 9.8 times height gives you the energy at 500,000. C is the correct choice. Here again, circular motion, the force is always toward the center of the circle. The guy is moving this way, turning this way. The force will be this way. A is the correct choice. Here again, the work done against gravity will be equal to lifting the weight up to this much height. You don't have to ignore this distance it is covering because this is the gain in the work done against the gravity. So multiply 0.8 with 2 using the gravitational acceleration gives you 1600 joules as the work done. 31, mass and weight. Okay, read through all this and you will know that, and you should know that weight is the force of gravity pulling. Every other thing is wrong. So here again, limit of proportionality, as long as a point is on the straight line, it is the limit of the proportionality. After this, there is no more straight line, so the limit of proportionality has been reached. It is B. In this one, the highest potential energy will be at the highest point, so A. This one, a bit tricky again. So a motor moves something to 1 meter. Okay, so you have to calculate the work done first. So 1 meter means force times distance. Force is 12, 10, 8, and 4. So the 12 Newton force times 1 will give you 12, and then divide it with the time will give you power as 12 divided 10. Why we haven't considered these two? Well, look at the question. It is saying that the hook and pencil are balanced on the edge A. Load is pulled by a rope attached to a motor. The resultant force exerted by a rope on the load is shown in the diagram. In each diagram, the load moves in the direction of the force and takes 10 seconds to travel 1 meter. In which diagram does the motor work with the greatest power? So you calculate everything else, the power will be less. That's why we have chosen A. 4 objects, different masses. Gravitational field strengths are different. Which has the greatest weight? We just multiply the mass with the gravitational mg, 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 mg. Look at his working. He has worked everything out and C is given the correct choice. So this is how you do these type of questions. And again, limit of proportionality, A, because it's on the line, which is straight. And this question we've done it so many times. So when you have a load L with two springs, and then you take one spring off, the load will exert double force on the spring. The spring's extension will be doubled, so it will become 2x. When you move another spring down here, its extension will also be 2x, the total extension of the two springs. That's what it is asking. It will become 4x. Here, the question says that smoldering rope, the burning rope at the opening of this container, and we have a candle. So look at the candle. The candle is making the air less dense. Okay, the burning candle is making air above less dense, so it moves up. The air moves up. When this air moves up, the only way for air to come is from here. Okay, because that is a denser air and it is coming from here. So denser air will come here, but the smoke will go out in this way. Why it will go out this way? Why no other place? Because look at the air. So the air is like moving like this. So in order to replace this air, air has to come from here. Here we have smoke, so that's why the smoke is coming down. The air at the bottom, remember in convection, the air at the bottom, if you heat something at the top, the bottom will still be denser. It will not move up. If you heat something from the bottom, then the air at the bottom or the liquid at the bottom will become less dense and will move up. So remember this tricky thing. If you heat something from the top, the convection will not take place from the bottom. It will take place only at the top. That's what it is happening here. 39, it is a mathematical question. So each tire has an area this much, mass of the car this much. What is the pressure? So the car has 4 tires, okay? Mass of the car will give you the weight of the car, 16,000. 16,000 divided 400, because 4 tires. So 16,000 divided 400 gives you 160 divided 4, that gives you 40. C is the choice. Number 40. So mass 10 kg, falling freely. Moon surface, acceleration 1.6. Gravitational acceleration, well, you don't need anything. It's just, you need to know what is the acceleration of gravity at moon surface, and that's what it is asking. The gravitational field strength is equal to the acceleration it produces for any falling object. So it will be 1.6. Thank you very much. I hope this will help you in good preparations. Wish you all the best.